Okay, so this one should be the paper for your saponifications. Okay, we see what you need to fill in the blank. For the student, you got printer. That means you can straightforward to type there to write the answer. For the student, you don't have any printer. That means you need to copy because that one is a paper. They must have the report. Okay, so from here, I'm going to show the answer for this one, the experiment. Okay, so for this one, first part should be the aim lah. Aim, we want to study the process making the salt through the reaction of palm oil. The first one using the palm oil. Another one you add the sodium. That one should be the concentrate sodium. Okay, and the last one they got acid. The one is a hydroxide solutions. So this one is a three thing we go to react together with the palm oil. Then they produce the salt. Okay, how can the salt be prepared in the lab? So from here they got hypothesis. Okay, they can be prepared the palm oil and the sodium hydroxide solution in the what process? The process is called saponifications. Okay, this experiment process name. Okay, after that what we control? So we control is the boiling of the mixtures of the palm oil and also the sodium hydroxide solutions. That means they're using how many sodium. That one is depend for yours. If you're using more, that means your what your products should be differences. So we need to control this one as a manipulate variable. Okay, then we continue. Okay, responding variable here should be the production of the salt. Okay, later that one, the outside after you do the experiment, the production, that one should be your responding variable. Okay, responding variable normally we cannot control because there's a result, is it? So from here, constant variable is the concentration of the sodium hydroxide solution and also the volume. This all must be constant value. Okay, now we see the first step. They say they mix the two substances. First one inside the beaker already got the palm oil. After that, they mix to the concentration solution, hydroxide solutions. Okay. Then after that, they need to heat it for 5 minutes. Okay. You need to stir. When they heat, you need to stir evenly. Okay. After that, number 3, they say they add the distilled water and also the salt. Okay. Add the distilled water for the salt. When you add the salt, that means they can produce some of the solid, just like the solid, because the palm oil only liquid, is it? You add some salt, that means later you can feel a little bit solid to produce. So they also put the distilled water together with the sodium. Okay, so part 4, they say they heat again for 3 minutes. Okay, they let the salt, they will mix together with the oil. Okay, then after that, they filter. Okay, what they filter is just now the salt join with the palm oil, they got reaction. After that, they need to filter the products to come out. So after that, when they just filter, okay, some of filter funnel, all this all thing we need to get it. Okay, so from here you take a little bit, put inside the water, then you go to shake. Okay, after shake, you see what happened. Okay, you see what they produce. Number 2, using your finger go to touch. Okay, what you can feel about that. So from here, the procedure already is there. I call you the procedure you need to write in passive form. Okay, in the question is active. It can become the passive. So the of the concentrate sodium hydroxide. Okay, then after that was added in the 10 cm cube of the palm oil in the beaker. Okay, now the mixtures of the boil for 5 minutes while the stirring the mixtures. Okay, number 3, the fire was turned off 50 and also the 50 cm cube distilled water and 3 spatula of the sodium chloride powder were added together with the solution in the beaker. Number 4, the mixtures was boiled again for 3 minutes. Okay, after that, number 5, the products in the beaker was filtered. The residue was be rinsed with the distilled water and was dried with the filter paper. And number 6, the following tests were performed on the solid form. There's the first one, the solid was touched by using your finger. Number 2, a little solid was shaken together with the water in the test tube. Number 3, the mixtures of the solid and the water were tested with the moist red litmus paper. So this one, moist red paper, means what they want to find out is alkaline or acid. You'll find there's a blue color, that means there's an alkaline. If they find the chain become the red color, that means there's a solution is a acid. So from here, we need to write the result. Okay, first one, when you touch the solid by using your hand, you find it becomes smooth. Okay, just like the bubble. Just like go to wash your cloth. After that, you touch about the detergent, you find it becomes smooth. The situation like this. So from here, they say slippery. Then continue number 2, we get it. Okay, after you go to shake together with the water, you find it like a bubble. Okay, lots of bubble are produced. And the last part, you test the mixture by using the moist red of the litmus paper. They become blue color. Okay, so that means your products, that one is a blue color liquid. That's an alkaline liquid. And also they produce a lot of the bubbles, and the feeling is a slippery when you just touch it. So we can prove they want just like the one type of the characteristic for the salt. Okay, so from here we need to answer about the discussion. What is the light yellow solid form? Okay, they produce is a light color, just like the yellow color, because you got palm oil. Palm oil is a yellow color, so they got a little bit yellow color. So this one, what they form, there's a salt. Okay, what is the equation for this experiment? There's an oil joined together with the alkaline. Okay, concentrate alkaline. After that, what they produce? First one sure is a salt. Another one is a glycerol. Okay, this one is the equation for the saponifications. Okay, name the process. Process is a saponifications. So what's the function for the sodium chloride in experiment? So that means why you add the sodium, you want to add in. So the function is you want to precipitate the salt for the solution. You want to make it got a little bit solid. Okay, because say mendakan for the Malay lah. Okay, that means you can find something is joined together like the solid. They're not all liquid. Okay, so that means this all mendakan. That means later they want to test is it there's a salt or not. So we call it as a to precipitated the salt for the solutions. Okay, number 4. Okay, so from here they said you need to concentrate it. Okay, which one is the solution can be replaced the concentrate sodium hydroxide. So that means which one can be represent the alkaline. Okay, except we're using sodium hydroxide. So another one should be the, remember when the name is a hydroxide, that one sure is an alkaline. Okay, they got one pattern one. Okay, one family, the name should be the same. So one is a sodium hydroxide, another one sure is a potassium, this is Malay, potassium hydroxide. So potassium hydroxide also one of the alkaline. Okay, another name. So remember behind for hydroxide, the one is an alkaline. So the salt is salt is what? There's a salt of fatty acid because you add the sodium. So there's a salt of the fatty acid. And the number 6, you take the example for the fatty acids used in the making of the salt. So we never using acid. We're using the example fatty acid. Okay, example fatty acid, remember for alcohol. Alcohol we're using acid, is it? So that one is some of the fatty acid we make about the salt. So from here, I think this one is not in your syllabus. So I just tell you what is that lah. So from here, they're using 2 types. Okay, lauric acid and also palmitic acid. Okay, so this one is an extra for the question lah. They're not related for this one experiment. Okay, then after that we go to the number conclusions, the last part. Okay, conclusion, first one, you must answer the hypothesis is accepted. Okay, you must mention this one. Then say number 2, the salt is made through the reaction between, then you need to mention the palm oil and also the sodium hydroxide, is it? Sodium hydroxide, there's an alkaline. In the, what process name? Saponifications process. Okay, so this one is your complete for your paper. Okay, so we go through to the next part. Okay, next part is your 6.1, electrolytic cell. Okay, electrolytic cell. So electrolytic cell is about the chemistry lah. Okay, about the chemistry. Okay, let's see the diagram. Okay, this one is a process of the electrolysis. Okay, electrolysis, that means we're talking about the ions. We got positive ions and also the negative ions. When they just put inside, okay, this one we call what? Solutions. This one solution, we call it as an electrolyte. Okay, electrolyte solution inside got ions. They got positive ion and negative ions. But this one ion, if no electric, they cannot move. Okay, so you must join with the battery or you join with the power supply. Then the electric inside the ions, they can move. They can separate positive and negative. Now you can see here got two plates. Okay, this one called electrode. Okay, the plate join with negative terminal, we call it as a cathode. So another plate that join with the terminal positive, we call it as a anode. Okay, anode. So from here, because just now I said you join the battery, then the electrolyte, the ion can be come out, is it? When the ion just come out, that means they will go find positive and negative. Okay, that means just like when you just release from the school, you back home, is it? So where you go to back, so you need to follow the directions. So you see the negative ions, we call it as onions. Okay, another one is cations. Okay, anions and also cation. So you can check like this. Cation, so positive must go to find negative. So they will find the cathode. Okay, another thing the student they tell me how to memorize. C and C must together. Okay, cation must go to find cathode because there's the same family because C and C. Okay, then another one is anion is A. A must go to find A lah. So anion is a negative, they must go to find positive. So A and A, they join together. Okay, so remember this one situation must happen when the key is closed. When the key is closed, if never closed, nothing happen. Okay, so this one process we call electrolysis. Okay, the electrolysis. First one, there's a electrochemistry. When you see the word electrochemistry means electric joint chemistry lah. Okay, so from here, electrochemistry is a relationship between the electrical, okay, and also chemical phenomena. So that means you want the chemical to happen, you must have the electric law. Okay, or you terbalik, you want to produce electric, you must have the chemical. So two also can be used each other. You can say electric produce chemical, chemical also can produce electric. Okay, example you can try by using your the lemon. Lemon, have you tried before? You using the lemon. After that, you join with the what conductor. Maybe you're using the nail, the metal. You put in the lemon. After that, you clip the crocodile clip. After that, you join with the bulb. You can see the bulb can be light up. That one means what? Chemical chain become electrical. Okay, electrical go chemical, everybody know lah. Just now I show you already. When you join the battery, then the iron start to move, is it? But the terbalik chemical produce electrical, you also can be tried. Okay, by using the lemon, they can produce electricity. Okay, so from here we just see the electrochemistry. What is that? Electrochemistry. Okay, let's see electrochemistry separate by two. One is an electrolytic cell, another one is a chemical cell. Okay, electrolytic cell means what? Electric go chemical. We call electrolytic cell. Chemical cell means what? Chemical produce electric. We call chemical cell. Okay, two things is a different things. Okay, now we're going to see one by one. Okay, we go to see electrolytic cell first. Okay, electrolytic cell means what? Electric current flow through an electrolyte. Okay, remember electrolyte, that means just now the liquid, electrolyte. Electric current flow through the electrolyte, then they produce the chemical. So just now I show you the diagram. When you just on the battery, that means the current will flow through the liquid. That liquid we call electrolyte. Then the liquid can produce the chemical reactions. So another one is electrical energy convert to the chemical energy. Through what process? process we call electrolysis. So now we go to the chemical cell. Okay, chemical cell is the balik. Chemical produce electric. So from here they say chemical changes that occur in the cell produce an electric current. That one called chemical cell. Okay, so make sure you differentiate what's the electrolytic cell, what is the chemical cell. So this one is a chemical energy convert to the electrical energy in the cell. Okay, this one you can try by in your house, not just only for the lemon. Sometimes they're using the potato. Potato also can conduct electricity. Okay, so this one is one of the chemical cell. Okay, then we go and see the electrolysis. Okay, this is a diagram for the electrolysis. Same like just now, must have the battery. Battery is a source. So from here, when the battery just on, electrolyte. Okay, electrolyte, they start to functions. How to function? The anion and also the cation, they will move. Okay, how they move? The cation must go to find cathode, because there's a negative ion, they go to find positive cathode. Okay, positive electron. So the anode is a negative, then the anion is a positive cell. They must go to find the anode. So A go to find A, C go to find the C. So this all process we call electrolysis. Okay, electrolysis we go to explain. Electrolysis is a decomposition of the compound in the molten or aqueous. Okay, molten means liquid solutions. They must in the situation is a solid, also with the ions. Okay, you cannot say solid. Solid cannot conduct electricity. They must in the molten or you say aqueous. Okay, state into the constituent element when the electric current flow through it. So they must constituent means the closer susun element. That means the element already arranged. Okay, they must in the arrangement. Okay, and also they must in the molten form. Then they can conduct the electricity. Okay, so this one is what electrolysis they need. Okay, remember molten or you say aqueous. Then the arrangement element must. Then after that, when the electric current flow through. Okay, and the electrolytic cell is made up of. Okay, you can see the diagram. Okay, electrolytic cell is made up of the. Okay, all the structure just now I explained already. Now I show you in the word. Okay, this one is an electrolysis process. First, you must have the battery. So the battery we call electrical source. Okay, number two, anode. Anode is one of the electrode. You see the black color one. That's made by the carbon. There's a positive terminal. Okay, when they join with the positive lah. How I know this one positive? Because they join the battery positive ma. So they call it positive terminal of the electrical source. Okay, cathode. Cathode is another one when they join with the terminal negative. So this one called it cathode plate. Okay, now electrolyte is what? Electrolyte is this one liquid. We call electrolyte. That's in molten form. Okay, they contain about positive ions. Positive ion is a cation. And also negative ion. Negative ion called what? Anion. Okay, so this one is what is the structure about the electrolytic cell. Okay, the diagram must be like this. Okay, so normally the question how to come out, label. You need to label the name. Okay, so from here, remember the anode is a positive. The cathode should be the negative. Okay, now we're going to see again the electrolysis. Okay, in an electrolytic cell, the battery is an electrical source. Okay, battery become the source. There are two electrodes. Okay, which are anode. There's a positive. There's a cathode. There's a negative. Electron flow from the anode to the cathode. So electron how to flow? The electron will start to flow from the positive. The current how start to flow from the positive must go then through the electrode, then after that go up, go to the negative, go to emitter, then go back. This one is a one complete current flow. So from here you can see the ammeter A is used to measure the electric current. If the current got flow, that means ammeter, they will show the deflected. Okay, the needle will be deflected. When the needle just deflected, then we know now the whole process is running. They got current pass through. Current pass through means the electrolyte, the ion, they start to move already. Okay, so this one is a process for the electrolysis. Okay, component in an electrolytic cell. Okay, we got electrical source, just now told you already. That's a battery. Electrical source in the electrolytic cell is produce the electric current to carry out the electrolysis. Number two, we got electrode. Electrode is a just electric conductor that's connected to the battery and also enable the electric current to enter or the leave the electrode during the electrolysis. So what's the function for the plate? The plate, the first one, they join with the terminal battery. So the battery will send the current. Okay, send the current go to electrode. After that, from the electrode, the current will be released. Release go where? Release go back to the battery again. So that one we call one complete process. They must from the positive go to the electrode, then back to the terminal negative of the battery. That one we call complete. Okay, so from here, this is one of the diagram. We also can say same like the electrolysis. Okay, because they got two electrode. Okay, electrode is the black color one. So from the positive, go in. Okay, after that, from the electrolyte, that through the ion is moved lah. When the ion just move, after that, the current will pass, go back to the another electrode and go back negative terminal. So this one is an anode, one is a cathode. So anode is a electrode connected positive. This one should be the anode. Then the cathode is the electrode connected to the negative. Okay, so that means we just see the connection of the battery where they go to join. Okay, when it just go to join to positive, then we call it as an anode. Then the negative show is a cathode. Okay, electrolyte. Electrolyte, that means just now the liquid. Okay, electrolyte is a substance in the molten or you say in the aqueous state which allow the electric current to flow through. Then and also undergo the chemical changes. Chemical changes means the ions. When the ions start to move, we call chemical changes. Okay, they consist of the positive ions, we call it as a cation. Another is a negative ion, we call it as a anions. Okay, non-electrolysis. Non-electrolysis means they cannot conduct electricity. We call non-electrolysis. The substance which do not allow the current, electric current flow through. Okay, how don't let the electric current to flow through means that cannot produce positive ion and negative ions. I mean, when you just on the battery, they also cannot produce the ions, means this one is a non-electrolyte. Okay, how to know they can produce ion and cannot produce the ions? Okay, we're going to see the table. Okay, later I show you the table. Okay, the table is like this. Example. Okay, you can see what's the differences. What is the electrolyte? What's the non-electrolyte? Okay, normally the electrolyte, you can see the name is two. Two joined together. You see, molten lead to bromide. Okay, brought, you see something, lead 2 is another thing. Then after that, bromide is another thing. Bromide, two of the material joined together. So this one is normally is electrolyte because they can separate, they can separate positive ion and negative ions. So another one is a sodium chloride. Sodium is a one of the chemical. Chloride is another one. Then when they just separate, they can separate positive and negative. Okay, after that we got hydroxide solutions. Sodium hydroxide, two things. Then copper sulfate, so also is a two things. Okay, you see the non-electrolyte. Non-electrolyte, there's a one name only. Although inside got carbon and hydrogen, but already mixed, cannot separate. So we got naphthalene. Okay, we got acetamine. Then we got glucose solution. Then the last one, ethanol. So these all is a non-electrolyte. That means they cannot separate positive ion and negative ions. So normally we never memorize, right? We just see the name. When the name got two mixed together, that one sure is a electrolyte. Okay, so for example, electrolytes are the ionic compounds in the molten or you say aqueous state, which consists positive ions, cations, and also the negative ion anions. So from here we can write example NaCl. There's a sodium chloride. Okay, sodium chloride, the sodium ion is a positive. Na is a positive. Then the Cl sure is a negative. Chloride is a negative ions. So when I just write the equation, there's a NaCl. When I just separate from the electrolyte, when you just separate, they separate Na positive plus Cl negative. So the Na will go where? The Na go to find cathode. Because this one positive, positive go to find the cathode. So how about the Cl? Cl is a negative, negative go to find positive. So they want to find anode. Okay, so this one is how we go to separate, okay, for the electrolyte. Non-electrolyte, we cannot separate anything. So that means when you put the non-electrolyte, you on the battery, actually is nothing happen. Electrolysis cannot happen. Okay, electrolysis process. Okay, example. During the electrolysis process, positive charge, that means the cation, they move to the cathode, negative electron. Okay, how about the negative charge? Negative charge is the anion. Anion must go to the anode, positive electron. So from here you can see the diagram. Okay, this one is a positive terminal. So this one is the anode. This one, another one, electrode. They call it as a cathode. Sorry, terbalik is it? Okay, negative, negative is a cathode. Positive is an anode. So the charge later, the ion, you no need to memorize. Important, you memorize the plate first. Okay, when you memorize the plate, then the plate positive is a A. Negative is a C for the plate. So from here, we go to explain. So from here, the electron will flow from the cathode. There's a negative. Okay, negative, they come out, go to the cathode. After they do the anode, anode is a positive. So you see the electron. Electron flow is a terbalik with the current. So remember the current, how to flow. The current is from the positive, go negative. Okay, for the electron is terbalik. Electron is opposite direction of the current. So the electron will flow from the negative. Okay, after that go to positive. So that means that from the cathode negative, then they go to the anode positive. This one is the direction of the electron, how to move. Okay, current it must from the positive and come out, then go back to the negative. So remember, positive charge and electron is the opposite directions. Okay, number 2 is, okay, what will happen if the molten lead 2, okay, molten lead 2 bromide is changed into the solid lead 2 bromide. So you think about that. This one is a molten. Molten is a solution. If I change this one, molten becomes solid, what happened? Okay, what happened? So the answer is electric current cannot flow. The electric current cannot flow and the electron cannot be carried out. So that means no electrolysis because the ion cannot move. What you are in solid. So there are no moving free ions to the cathode conduct the electricity. If no ion flow, means the whole process cannot be functions. Okay, cannot be functions because you just provide outside battery the electricity, but inside is nothing to move. So this one is a situation which cannot be happen when they're just in the solid state. Okay, they must in a molten state. Okay, now if in the molten state you can see lead through bromide, what happened? Okay, Br bromide is in the negative. That's a negative ion. Negative ion must go to find anode. Okay, Pb is a lead 2. Lead 2 is a positive. Positive must go to find the negative plate. That's a cathode. Okay, So from here, you see, for example, during the electrolysis of the molten lead to bromide, okay, Pb is a lead, Br is a bromide 2. Okay, now positively charged, there's a Pb. They must go to move to the negatively charged, there's a cathode. Okay, how about the negative charge? There's a bromide. Bromides must go to find positive, is it? So they go to the positively charged, there's a anode. Okay, so just a simple thing. Important, you need to know the ion how to move. Okay, positive must go to find negative, and the negative go to find positive. Okay, so which one positive, which one negative? The question will be tell you. Okay, normally they mention the positive first lah, then followed by the negative. Pb, Pr. So the Pb normally positive first, then the other one should be the negative. Okay, so this one just the introduction for 6.1. Okay, so important, we need to know label. Okay, the labeling and also the name. So what we need to do, I upload already in your GC. Okay, in your GC, they got 2 exercise. Okay, first like this lah, electrolytic cell. Another one also almost like that. You need to labeling. So you need to print out and fill in, then upload. Again, PBD. This one is a PBD, important. So you need to do, must do. After that, another one should be your Google form. Today got Google form. Only got 2 questions, simple question. And they got the code, lesson code. Okay, anybody is volunteer to type here. The code is 2021 hashtag. Okay, there's a number 2021, then hashtag. Okay, that one is today lesson code when you want to do the Google form. Remember, yeah, thank you, Dixon. Okay, so one more thing is Google form must log in by using MOE mail, no Gmail. Okay, remind you again, MOE mail. Gmail cannot log in. So only MOE mail you can log in and answer 2 questions and type the lesson code. Okay, please type your class, your correct class. You are 5A2, you type 5A2, you don't go to choose 5A1 again. Okay, so this one is what I want to perform to you. Take my pass up and 2 exercise today I upload, you need to turn in. The due date is when? Tomorrow. Tomorrow, 11:59 p.m. You need to pass up. Okay? Then another one should be the Google form. Today you need to fill it. Okay? So the code they already typed in the chat room. So you retype again in the Google form. Don't copy and paste. Copy and paste, maybe the system cannot accept. Okay? So that means today the last one is thank you. So thank you for you all, and also remember to pass up the paper. Okay? Okay, bye.